Presenter, who's far better than Brian Cox, incidentally. Yeah, we have our very own Dr. Chris Empson. Give it up for Chris, come on.
Ready. Okay, so tonight I'm going to take you to the very frontiers of human understanding. I'm going to tell you about a particle physics experiment that took place a couple of months ago that appears to call into question Einstein's assertion that nothing can travel faster than the speed of light, okay? So in 1905, Einstein, this is him, obviously, published his theory of special relativity, which gave the world his famous equation, E equals mc squared, but it also said that nothing can travel faster than the speed of light in an absolute vacuum. So, we appear to have a slide missing here, but the speed of light in a vacuum is very, very fast, and basically it could travel around the world twice in the time it takes you to blink. Light is made of photons, and this is the standard model of particle physics. Photons are up in the top corner, but today I'm not going to talk to you about photons. I'm going to talk to you about neutrinos, and there are three flavors of neutrinos: the electron neutrino, the muon neutrino, and the tau neutrino. And in this experiment, what happened was, and I'm missing another slide again, I think. Neutrinos basically are all around us. They're very small, they have no mass to speak of, they have no electronic charge really, so they don't really interact with anything. 70 billion of them pass through your body, every square centimetre of your skin, I should say, every second. But they don't interact with the atoms in your body, so you don't feel them, so you don't really know you're there. This is the Super K experiment, which can detect them. This is in Japan. All these little yellow balls surround a big tank of water, and sometimes a solar neutrino interacts with that water, causing a little flash, and those balls detect it. But it detected something really strange, and the three flavors of neutrinos can kind of swap between each other. So this opera experiment here is in Italy at the moment, big chunks of lead, that detects neutrinos from the Large Hadron Collider. And this is the large experiment that you've probably all heard of. They whiz protons around here at most of the speed of light, they send some off into a big piece of metal. And this piece of metal is aimed at that big opera detector, those big sheets of lead, and it travels through the Earth 450 miles from the French-Swiss border over to Italy. We'll see that in a minute, hopefully, with the next slide. Yeah, there we go. So neutrinos pass through the Earth, the distance is calculated very carefully, and it's all timed with GPS satellites and atomic clocks, and they've done all the maths really carefully. But they came up with a really odd result, and it's really baffled all the physicists, because those neutrinos appeared to arrive at Gran Sasso in Italy, where this experiment's taking place, 60 billionths of a second before they should have done, before light would have got there if it had travelled through a vacuum. So this was really baffling. It's just skipped 2 slides. No, I'm baffled. It skipped another 2 again. Okay, not to worry, we'll carry on. If something travels, those neutrinos appear to be travelling faster than the speed of light. Now, what does that mean? So, if I was to take a ball and throw it at Ivor, he'd be able to see the ball coming. He'd be able to either catch it or get out of its way before it hit him. But if I was to be able to throw a ball faster than the speed of light, he wouldn't even see it coming. The light bounces off the ball and goes into his eyes to enable him to see it. It won't be able to get there before the ball will. So effectively, the ball would have travelled backwards in time from Ivor's point of view, which is exactly what these neutrinos seem to be doing. Now, there could be a few reasons for this. Maybe they pass through a wormholes on the way and some extra dimensions in space, but we've no evidence for the extra dimensions, so that can't be happening. Maybe they're just giving 110% like they do in the X Factor and just going that little bit extra too fast, but maybe not. Or it could just be that the Italian physicists at the detector have just been drinking too many espressos, and everything just seems to be going really, really, really fast. But the speed of light is invariant with respect to the caffeine intake of the observer, so that can't be true. And of course, nobody's seen a paradox. Nobody's seen, something travelling faster than light, and nobody's seen an effect before its cause has taken place. that can't be right either. So unfortunately, I think someone's just made a cock-up. Someone's made a mistake. Someone's measured the distance wrong, or between the two experiments, or they've got the timing wrong or something. But that's all still to play out. So keep an eye on the news in the next few weeks, and you'll sort of see what's happening. And I hope you're as keen to see the results as I am. Okay, thank you.
Dr. Chris Empson, thank you.